Hey guys, I'm Nick and welcome back to another Houdini tutorial. First of all, a few days back I added a poll on my Patreon and asked your opinion about walkthrough tutorials versus step-by-step like my tire burnout / colored smoke one. And because we've got a pretty close results, I thought maybe we will be mixing walkthrough tutorials and step-by-step tutorials just because some of them might actually need a step-by-step to show you all the variables and attributes and better explain what each node does, and other tutorials like this one could be more like an overview of the technique plus sharing a few cool tricks, cool hacks if you want. And yeah, this one is very much inspired by this older artwork by David McLeod. And actually, this tutorial, this kind of bonus tutorial, because there will be another one pretty soon, my mentee John asked me about creating this effect because his client actually needs something similar to be done. So yeah, here we have this tutorial, and by the way, yes, I have one-on-one mentorship if you need a bit of assistance going into commercial motion design world. So feel absolutely free to hit me up on Discord, Patreon, email, whatever works best for you, and I will be happy to answer all of your questions. So here we are in Houdini, and we have, as usual, we have our main geometry, we have our grid, which is our backplates, camera, material network, and one RS light dome with my favorite brown photo studio. I unchecked this enable in viewports because if I enable it in viewports, all my solid bodies become this metallic material, and I don't like that. So yeah, just uncheck the enable in viewports. So what we have here is a pretty simple setup, which consists of the shapes that we will be then inflating and kind of expanding. So here we have our torus, we have our sphere, we have our platonic dodecahedron, which radius set to 0.8, and we also subdivided it for our Vellum solver. And pay attention that we are using open subdiv bilinear, which basically just adds loop cuts, because if we go with Houdini Catmull Clark, you can see that it will actually kind of be your main and that subdivision algorithm everyone uses, right? So open subdiv bilinear just to add a few polygons, and then I made this ugly plus sign, basically, yeah, with the remesher, and yeah, just a plus sign. You can use whatever shapes you want. We will be more focusing on actual Vellum solver, and I want to share a few tricks with you here. So yeah, grab whatever you want. You can just use spheres or yeah, whatever. Just make sure you merge it all up with the merge node here, and then you add UVs because UVs are crucial. I'm using Labs Auto UVs. Now you can see that we have UVs on our vertices, and then yeah, copy 2 points with a random distribution of our objects here. Let me just turn off the grid for now. So I want to randomly distribute all these shapes on points of this box you can see here. Basically it will be 3 by 4 by 2, and that's just because I'm rendering it vertically for Instagram. You could go with whatever shape you want. So after our UVs, we drop a connectivity node, and here you can set your attribute to be whatever you want. I just set it to be obj. You can set it to be index, for example. Let's set it at like index. And then we want to grab this attribute from pieces node, and pay attention that we plug the connectivity to the right input, and we can obviously bypass this attribute wrangle. We will get back to that a bit later, but we plug our box, which will be the points, the point cloud. It goes into the left input, and here in attribute from pieces we want to use that same attribute that we specified in the connectivity node, and we go piece attribute, set it to be index, and here the mode can be cycle, can be random, can be whatever you want, noise, patches, you can even use the expression for distribution of your pieces. Yeah, it's cycle for now. And here in copy to points in the right input, target points to copy to, we grab our attribute from pieces, goes here into the right input. In the left input goes our connectivity node. And very crucial thing is here in the piece attribute. For now, we want to set it to be index. You want to check that checkbox and write down your attribute that you made here in the connectivity that you copied into attribute from pieces. You want to copy that into the piece attribute of your copy to points to. So it's index in all three of them. And here you can see all of our shapes. So yeah, looks pretty good. The only thing I wanna add a bit of random in scale and maybe rotation for them. So between the box and the attribute from pieces, I drop this attribute wrangle. And what I do here is I set the P scale to be random number from 0.5 to 1. So function rand, it needs sort of a seed, which is ptnum, which is the number of each of these points that we have here in our box. And you can see all these points have different numbers if I visualize it with this display point numbers. So this function rand will now get us the float, which will be in the range of 0 and 1. And we want to remap that range because we don't want the objects to be too small. That will produce artifacts in our Vellum. So we want to remap, and to remap we use this function fit01, which takes the value in the range 0 and 1 and shifts it to the corresponding value in new range. And new range is basically what we specify next. So first of all, you can see here it takes the value, then nmin and nmax, which is new min and new max. So basically it takes our result of the rand function, which will be any number from 0 to 1, and we shift that range to be from 0.5 to 1. So yeah, that's our P scale. You can set it to be from 0.7, 0.2, 0.3, whatever you want. And then I set the orient to be equal to normals, so it gives a slight rotation based on the normals. So yeah, here's our basic setup of different kind of clones, different objects, copy it to the points. Then we want to drop this Vellum close and Vellum pressure, but there is an easier option. You want to just drop the Vellum balloon, configure balloon, and then you will see it drops both of these nodes, Vellum close and Vellum pressure. So for the Vellum close, I have the mass set to 0.01. Then I have the stiffness set to be maximum stiffness. Damping ratio actually set to 0.01. And for the bend, I'm using, I think the default stiffness and the default damping ratio actually. But for the pressure, I'm using stiffness set to 8 multiplied by 1000. Damping ratio set to 0.01. And pretty crucial is this output group, which I have named stretch pressure. We will be modifying the constraints in the DOP network, so that's why it's pretty important for us to keep these groups named correctly and named uniquely. So this clause stretch group is named just stretch, and this pressure group is named stretch pressure. After these Vellum constraints, we drop two nulls. One is outshapes geo and second one is outshapes con, because one is basically our Vellum geometry and second one is our constraint geometry. Also, you could see that we have some sort of invisible boundary, invisible collider for our shapes, and this is basically another box which is just a bit bigger than our initial box that we used to clone our shapes. So we can maybe select the copy to points here and then wireframe or template preview our collider box. Here it is. I also visualized my camera and I kinda aligned that box to be in the center of the frame. After our box, I just dropped the out collider, just a null for the better structure of this project. And then yeah, we go into the DOP network, and here is where all the magic happens. So you drop your DOP network, it will be just this output node. What you want to do is add your Vellum solver, then you add your Vellum object, and then you add your Vellum source. And I can just like bypass everything here like this. And so if I play it, yeah, it still works, but we don't have any forces. We don't have anything that will influence our solid body, so nothing actually happens. Yeah, just this merge should be active. In the Vellum source, of course, you want to specify your subpath to your geo and constraint subpath to your constraint. Those are these two nulls that we created. Let's go back to the DOP network, and yeah, let's begin with adding the collider. So drop the static object here, and subpath, you just select it here, out collider. Use deforming, use object, create active object, nothing, we don't need nothing. Just everything is default here, but we will be using volume collisions, and the only thing that we actually need to do here is check this invert sign, and that will basically create a collider that will basically tell the Houdini that we are inside the collider right now. So to better visualize it, we can add this pop wind here, or actually let's add this new pop wind. Let's set the amplitude to be something like 5, and activation, yeah, it should be already active. So now if I simulate a few frames, let's simulate 30 frames, you will probably see where we have our collisions going. To make it faster, actually no substeps at 1, actually everything is good. Yeah, just let's simulate these 30 frames. And so about this project in general, I made already a tutorial which was called Vellum Inflation, and the key thing here is to make sure you are not working with unnecessarily dense geometry, because for these shapes you actually want to keep the poly count pretty low. It will make your simulation faster, it will make your constraint iterations faster, and you won't get that much deformation that potentially could lead to the solving issues of the Vellum solver, of course. So yeah, here you can see that we actually have a few of these solid bodies. For example, this one bounce off the collider that we cannot see, but I can select it to be displayed, checking this display geometry, but then we don't see any of our shapes. But yeah, basically we have our collider here, and it works really good. So what do we want to do now is, maybe, yeah, let's let this pop wind to be here. We want to drop 2 Vellum constraint properties, and one should be stretch and the second one should be pressure. And so I want to inflate these shapes, but I want to make sure that as they are inflating, they are not becoming not like soggy, but I mean they should not lose their pressure. Because imagine if you inflate a balloon and then you make that balloon bigger, the pressure inside the balloon will decrease. So what we want to do here is, in this Vellum constraint properties, you can see that I am just keyframing this rest length scale for the group that is called stretch. So this group is basically the shape of our geometry, and if I will play it here from till the frame 30, you will see that rest length scale is set to 3. So let me just bypass this pressure, and yeah, let's maybe set the wind to be something like 2. And now let's play 60 frames of this simulation with just the stretch Vellum constraint animated. So as you can see, this looks pretty awful. So we are extending the constraints between these polygons, and you can see that we don't have any pressure, so we don't have anything that would keep our shapes in their actual shape. Let me bypass the file cache for now and just use Vellum post process. You can see that they are not too bad, but yeah, you can really tell that these don't have any pressure inside. And now let me just simulate the same thing, but I will enable this another Vellum constraint property, which is said to be again rest length scale, but on the group, which is our stretch pressure. And you can see that it is also animating from 1 till 7 at frame 30. And you can see a bunch of different keyframes here, but we will talk about them a bit later. So now let me enable this pressure constraint and let's simulate the same 30 frames here. Now you can see that the result is a bit different from what we had before. Of course, a bit of these shapes lost their form, but still it looks far better than it was before. And just for the sake of the, I don't know, experiment, let's set this one, the rest length scale here, to be 14. So let's double the value of the rest length scale for the pressure constraints. And let's simulate 30 frames again. So now you can see that we have that inflation for all of our soft bodies, and they actually kind of filled the collider shape with all the pressure that we gave them. And another experiment that we can do here would be getting back to our DOP network, and now for the stretch, let's set it to be 1.5 maybe, and simulate these 30 frames again. So what you will see now is these shapes getting inflated, but they are actually like bulging because the pressure gets bigger, but the shape remains as it was initially. So that's why we have them inflate like this. So when you will be creating this setup, you should be aware that for different topology, for different shapes, you may want to play with these values of stretch and pressure. Let me just get back with my 7 and 3 for the stretch, and yeah, 7 for pressure. And here you can see that I'm also animating them from 7 to 14, then back to 3, then back to 10. This is done just purely to make the simulation more interesting with dynamic kind of inflation and deflation of all of these shapes here. I have my pop wind, which was not this pop wind, but this previous pop wind. So activation is set to 30 because I want the wind to move all these shapes when they are inflated, because applying the wind just from that first frame wasn't giving me that result that I was looking for. And you can see that amplitude is set to 10, swirl size to 5, swirl scale to 2, pulse length to 3, and offset is basically changing every second, so it's $T. This is a very aggressive wind, but the main thing is that we will be retiming this simulation, so I actually want to simulate less with aggressive wind, with really like big and fast movements, so I can just retime, make it super slow motion, and then I can get that nice and smooth movement of my shapes. And also here with the gravity, I'm playing with this gravity too, because I want them to kind of move from side to side, up and down, and that's why I have my gravity also keyframed here from 0, where we don't have any gravity, then goes to -10, which is our default gravity, then goes to 10, which is reverse gravity, then it goes back to 0. You could maybe add a few more keyframes here and also play with the horizontal gravity. This is just to make sure that not only wind, which is essentially a noise force, but also I want a gravity that I want a force actually that will move all of these objects in the same direction. And then this force overlaid with the pop wind gives pretty interesting and nice result. So yeah, that's basically it for the setup. I have file cache, my file cache here for 150 frames, and here you can see how aggressive that wind actually is. But when we will be slowing down all of this motion, actually it is like in the preview, it's pretty smooth. Then I use this retime node, and you can see that speed is set to 0.25, and input range is set to from 50 to 150, and output range is set to 1 to 300. So you can see actually all of these movements are pretty smooth. Of course, I'm adding the Vellum post process with subdivision depth set to 2 and spatial blur set to 0.2, so everything becomes even more smoother. Then if we look through our camera, maybe set the subdivision depth to 1, and yeah, it's still not that silky smooth for the preview, but I think we are pretty close with this abstract effect to what John needs to create for his client, so I hope we helped him out with this effect. Also, I have my grid, which is just a reflection plate. Yeah, the grid where we have unchecked primary array visibility. In the Redshift OBJ tab, in the visibility tab, you will see all of the checkboxes. Just uncheck primary array visibility if you wanna render reflections but don't want to render actual objects. And in the material network, yeah, so I created the bump map that you can see in very subtle bump map that you probably won't be able to see, but yeah, just RS noise set to turbulence, complexity set to 4, amplitude gain set to 1, frequency scale set to 2.8, distortion set to 1.3, distortion scale set to 0.4, overall scale 120. Super crucial thing is to make your source to be vertex attribute, and vertex attribute name should be UVs, because otherwise everything will flow away. And also the very crucial thing that I just forgot. So here we have our retime. By default it will be like this, and by default you won't have this material here. So let me just remove the material and go back, and you will see your UVs here, actually here in your file cache, right? So here are your UVs. Now if you make retime, you will see that somehow your UVs are recalculated all the time, and we don't want that. So in the attributes that receive the interpolation, we want to exclude the UV, and to exclude, you want to go with a Shift 6 with this like upper semi-triangle, whatever it is, and set UV. So now you can see that we don't have our UVs recalculated or interpolated actually. So we can safely render it out, and yeah, let's get back to our materials. Overall scale set to 120, scale is set to 1, RS noise for the roughness, and yeah, I have just two materials, orange and this kind of white, I think white, yeah, and I render it 2 times. I think there would be a clever way to do this, but I rendered 2 different separated animations. One is white and second one is orange, and these 2 other squares that you see, they are just made in After Effects with the masks and just colorizing the orange version. So yeah, it's a nice little creative trick, I think, with a hue saturation effect, and yeah, the colorized checkbox checked, of course. So yeah, I think that's it for this quick little bonus tutorial. I think we might shift our schedule a bit, because yeah, I think this tutorial will be on Wednesday, because right now is Tuesday evening. Maybe the next tutorial will be then maybe next Tuesday or something. But yeah, I have a lot of tutorials prepared for you guys. I really hope you learned something new today. Vellum sewed bodies, or not actually sewed body, it's still a cloth with a pressure. It's something very fun to use and play with, and I hope that the techniques you learned today will come handy for both of your personal and commercial projects. But I will be back with another tutorial very soon. Bye!